Hello, everyone, and welcome to the latest episode of ARtillry Innovators, our video interview series with leaders in the AR and VR worlds. I'm Mike Boland, Chief Analyst of ARtillry, and my guest today is CEO of Visby and all-around industry thought leader on the topic of Lightfields, Ryan Dahm. So, Ryan, welcome and thanks for joining us.
Thanks for having me, Mike. I'm glad we finally got together to do this.
Exactly. This will be fun. So we have a lot to talk about, including your company, Visby, and Lightfields in general. And, Lightfields is kind of an interesting and funny topic in a lot of ways because, it's rooted in the basics of how our eyes and our brains process light and images. But at the same time, it's not so basic once you start to unravel it. So to tee you up to start to talk about Lightfields. I'll characterize kind of the high level for our audience and then let you jump in and kind of correct all the places I've botched the description. So at a basic level, for those unfamiliar that are watching this, Lightfields are kind of, the light rays all around us. And it involves the ways that photons hit our eyeballs and that our brains kind of render the physical world around us. So the art of Lightfields in immersive tech like VR and AR is to kind of recreate those natural vantage points in the most accurate ways. So to put that into perspective, by contrast, if you're watching a 360 video, which is I think a format that a lot of people are familiar with, you're really only seeing kind of one fixed vantage point. And though you can look around with 3 degrees of freedom, or what most people know of as head tracking, you're kind of confined to the vantage point of, what that camera initially shot from that point. So moving into positional tracking and 6 degrees of freedom, or being able to kind of move around more freely, what happens when then you're able to kind of take a step forward? And all the light rays in that new position are different. And the items in your field of view are now, they have a different relationship to each other and to you. Shadows look different, or they should anyway, depending on where the light source is. So I guess what I'm saying is the art of Lightfields in VR is to capture and reproduce that in the most realistic way. And some people might point out we already have that kind of positional tracking and rendering of volumetric spaces, but those are mostly with graphical experiences like games that apply a polygon approach. But really the holy grail, and what we're getting to with the Lightfield discussion, is that same 6 degrees of freedom with photorealistic, as opposed to graphical scenes. So what would you correct about that or add to that description?
Oh, that was pretty spot on. I think you kind of nailed it. I think bringing up volumetrics is a really good entry point as well, because that is a 6 degree of freedom experience. And there are people trying to scan the real world and get it into these virtual environments in a 6DoF way. But what that misses, of course, is it's not a photographic approach, right? So a light field is sort of only worried about the light itself, not about some underlying scene geometry. And that's all the difference. Yeah. So at a high level, that's spot on. I think the key thing to know is that light fields, though they've been talked about in academia for a long time, they haven't really been practically implemented in industry very much at all. So it's still actually a pretty young field. So there's a lot of rapid advancements.
Now, do you see that it's accelerated in terms of both the attention to it and the work done around it because of the kind of, inception, or at least acceleration in another wave of interest in immersive technologies like VR and AR that we've seen over the last 2 years?
Oh, for sure. I mean, if you want to look at commercial applications of light fields, even like 5-6 years ago, I think it was like the Lytro camera, and then there was something called Raytrix that was using like small scale light fields for basically for getting depth information for industrial applications. That was pretty much it. Everything else was happening at various academic labs, or artists were playing around. VR and AR, I think, is really the first practical application of these large-scale holographic light fields, because you need perspective generation, right? Which is something that a large-scale light excels at, which is great. It means that there's this burgeoning commercial market for it, and the tech is just running to catch up, basically.
Interesting. Now, one way I've heard you describe this, just kind of go a little bit deeper on kind of the definitions and helping people really visualize it, is the GOAT construct. And I guess, that sounds weird. People will see what we mean by that as you go a little bit deeper on it. But unpack that a bit, because I think it's a great way to kind of visualize what a light field is, an inherently kind of complex topic to wrap one's brain around. I think it's a good way to describe it.
Yeah, it kind of dives into like how light fields actually work, right? So mechanically, the GOAT, my sort of spirit animal in these talks I've given, is just sort of an example of subject matter, right? So if you imagine how you see the world, I think we all just sort of don't think about how we see, but when you try to interrogate what a light field is, what it's doing, it's useful to sort of build it up from basic principles. So you start with some subject matter, like the goat, and understand that you don't actually see the goat in 3D. I mean, to experience something in 3D, like touch is your only sense that's really 3D or proprioception. Sight is actually taking a series of two-dimensional images and building them up to develop your sense of the world. And it does it solely through a series of two-dimensional images that are basically sampling the light that's in a space, right? So if you imagine all the light bouncing off of a subject matter or being emitted from your subject matter, that's actually the only thing you're interacting with. So as that light bounces off the subject matter and enters your eye, that allows you to serially build up your understanding of the world. And so the idea behind a light field is if we capture all of the light in a large space, and then we can recreate it, whether it's in a headset or on a mobile phone or in some very practical photographic way, in other words, getting as close as we can to the actual light rays, then what you'll experience is essentially a true image, exactly the way it appeared in reality, right? Not something that's a simulation or looks off. It's actually what you would have seen. Another way of saying is that we don't actually experience the world directly. We experience it in this way that's mediated by light itself.
Now, the other kind of the way I've heard this described, and you can kind of jump in and correct me or add to it, but using that kind of example of looking at a goat or whatever the kind of physical world object is, you're essentially capturing all of the light in that space, but then kind of tracing it back to a 2D surface. And then that 2D surface has all of the information in it in terms of all of the possible angles of incoming light. And then that allows you to then kind of recreate it. Now, if you picture that as just like one big plane, taking that one step further, the way I've heard it described is, picture yourself in a box. And it's a 6-sided cube. And if you line all of the interior faces of that box with kind of one of those, flat things, like back to the goat example, you're essentially recreating, depending on where you are in that box, every possible combination of the light coming in. So that's another way to kind of visualize it. Is that, fair to say?
Yeah, that's precisely correct. And that's in practice what we do with light fields in a VR headset or an AR experience is on the fly, you take the user's position and their orientation and use that to calculate the light rays they would have seen, but you actually trace them back to that surface. Yeah. And that surface frequently in practice is defined by a big array of cameras or something. Yeah. But somewhere there's an actual surface that you're drawing your light rays from. And then they end up getting painted in your headset based on where they intersected that surface.
Mm-hmm. Now, one thing that really arises from that discussion is to have all of those kind of possible combinations of perspectives, because you're just recreating it by, again, tracing all of those back to a 2D surface so that you can then have all kinds of different combinations of angles and appropriate shading and all that good stuff. Now, one thing that arises from all of that is just the sheer data volume that results. We all think of video in terms of hundreds of megabytes or even in some cases gigabytes. This file for this recording, is probably going to be between 1 and 2 gigabytes. When we're talking about just all of those combinations of angles, bringing Visby into the discussion in terms of the kind of, getting across that data challenge, because you guys are doing a lot with compression. And I think one thing that you guys, the principle is based on, and the fact that because light fields have so much redundancy, they're inherently compressible. So you guys are working exactly on that principle.
Yeah, I think the best way to think of it is to imagine, the camera array you have to build. Yeah. The standard way to sample a light field is pack as many cameras together as close as you can, because what you really want is every single light ray. That's not possible in practice, but an uncompressed light field would be every single light ray across a large surface. If you actually think of keeping that at reasonably high resolution, you're talking about petabytes of data. Yeah. You end up sampling a much smaller subset of that. Even with these huge arrays of cameras that are shooting at terabytes a minute, you're still throwing away most of the light. So you have this dual problem in that you're dealing with a huge amount of data, but it's actually much smaller than the amount of data you even need. So you end up with aliasing problems and reconstruction problems. And at Visby, what we've come up with is some fairly clever ways to tackle both of those problems at the same time, in which we operate on much less data and then are able to compress it even further, but also reconstruct the signal that we want and actually display the light rays without the sort of aliasing and artifacts you would expect from kind of very straightforward approaches.
Yeah, that makes sense. Now, a lot of that deals with capture. The actual discussion of light field, when tackling a complex topic, you can segment it into capture and display. So we've kind of talked so far a lot about capture. Let's kind of drill down and display briefly. When we're talking about display, we have things like VR headsets and the positional tracking they inherently have make them kind of fitting for light fields. With that, like what's notable, and also where else are you seeing notable development? Excuse me. There's 3D panel displays that give you some degree of parallax, kind of like a magic window type of vision, and that's kind of like the unfulfilled promise of 3D TVs, and what's happening there that's noticeable.
Well, there's a lot of action. I would say, obviously, everyone knows about VR, and 6DoF for everything is around the corner, right?
Yeah.
So it's clear that VR is already ready for light fields. AR and mobile AR is pretty much here. I wouldn't say that light fields have actually bridged the gap yet, but they're going to. It's going to be how you get photorealistic content in mobile AR, and when we get like headset or glasses based AR, that's going to really benefit from light fields as well. And then the panel displays is very much still an emerging technology. We've seen a few demos behind closed doors. There's a bunch of interesting technologies out there, and actually a lot of different ways that display manufacturers are tackling the problem. Mm-hmm. But it's still a little bit farther from market. I think that I do think that VR and AR are going to kind of lead the way on content and capture, and that the panel is going to be the last thing that kind of backfills. Yeah. But it's our vision at Visby that everything's going to go holographic. Every screen, every device that's displaying stuff is going to be functionally multi-perspective. It's inevitable.
Sure. Now, when looking at all of the kind of options out there, we spoke earlier about more graphical and volumetric experiences in VR. We're talking now theoretically about the kind of promise of light fields. What are some of the kind of like use cases that you envision where light fields are particularly going to shine? And what are some where, volumetric or kind of polygon approaches are actually going to be just fine?
That's a great distinction. So, like, if you asked me 18 months ago, I would have said, "Oh, light fields are going to eat the world." VR, like volumetric approach is just transitional. And to pause for a little bit of definitions here, and we say volumetric, of course, we're talking about scenes that are basically like running in a game engine, right? So you've got polygons, and you've got some literal 3D environment, and you're drawing polygons with textures, and that's how you sort of create your images. The reason that's important is twofold. One, those type of approaches, I think, are always going to hit the ceiling of sort of video game technology.
Yeah.
Even if you're trying to grab the real world and bring it in, you're limited by the expressiveness of that particular representation. So they'll look a little bit like video games. That's the weakness. Now, the strength is also the fact that they're in this game engine, which means you have a high degree of fidelity around the objects themselves. You can manipulate them. You can interact with them. So these days, now that I've really took a look at what's being done and kind of have a more sophisticated view of the space, I would say that both are going to live alongside each other, volumetric and light field approaches. I believe the volumetric is going to really play well in situations where you need interactivity, right? If you want to do some sort of training simulator and someone has to actually manipulate objects or something and get real-time feedback, that's kind of got to be volumetric. I mean, it's just built for that. On the flip side, if it's more lean-back entertainment, if someone wants to see something that's just beautiful, light fields are going to excel at that. They're going to do things that are photorealistic, but play back on today's hardware without some major breakthrough in video game technology or rendering engine tech. People will look great because, again, there's no underlying model, right? It's just the light. If you get the light right, people look the way they look. Mm-hmm. So I see those two kind of playing alongside each other. So, different verticals use them in different places. And then eventually I think they'll hybridize. I think you'll be in situations where the stuff that wants to look great will be light fields, and then whatever object you're interacting with might be done in polygons. And maybe the savings by running backgrounds and so on in light fields will allow us to spend more compute on the little interactive parts. So the borders will blur a little bit. That's a little bit out there. That's just a guess. But, that kind of feels like the future.
No, that makes a lot of sense. And it also makes sense that polygons and volumetric spaces will exceed whenever there's a bit of interactivity, or just kind of it needs to kind of interact back, or some sort of action on the fly, as opposed to something having been previously captured. But it's also interesting that you mentioned kind of faces and things like that. I think that correct me if I'm wrong, one of the downsides of polygons is the inability to get realistic faces, which of course is a challenge in terms of the kind of uncanny valley thing that everyone always talks about. But particularly our brains kind of we don't receive that well when faces aren't right. Like other things that aren't right, like a wall or a lamp, we can kind of forgive that. But for some reason, we have this weird psychological effect whenever a face isn't right, whether it be skin tone or just animation. And that's one of the places where Polygon falls down, correct?
Yeah, well, and you nailed it too. It is a sort of a neural thing and a psychological thing more than it is
more
a physics of light thing. Yeah, I mean, the truth is we actually can pick up a lot of information about materials and so on just based on how light moves across the surface, right? So you can look at a table and you know if it's made out of wood or metal or plastic, and you don't know why. You're just sort of implicitly processing that. You do the same thing with humans' faces, though, and if the light doesn't look quite right, you suddenly conclude maybe this person isn't all the way there. Maybe they look a little bit like a mannequin or a zombie, or they look off,
Right.
and that triggers something really, really primal in us, which is why it's sort of a problem. The reason Lightfields can handle it, again, is there's no underlying model, right? You aren't running some scattering model for how light moves through skin.
Yeah,
You're
it's
just
just
trying
natural.
to recreate the light as you saw it. Exactly.
Yeah.
You sort of let the processing happen in the real world, right? And then as long as you can recreate it, you're fine.
Yeah. So this is all really interesting stuff. As a last question and kind of winding down here, one thing I always like to ask in these interviews is, from a kind of business or practical perspective, what are the kind of current pain points for Visby, or what keeps you up at night, or what types of things from a business objective standpoint are you now looking at? Is it technical talent? Is it funding? Is it partners? Is it suppliers? What kind of things, in case there are others out there in the audience here that are interested in kind of business development and looking for synergies with a company like Visby?
Yeah, boy, you saved the big one for last, Mike. There's a lot. I mean, almost everything you said there is relevant to us right now, right? It's hard finding the right technical talent for what we're doing, but we're trying. We're doing a decent job on that. There's never enough funding, that's for sure. We're having early conversations with kind of prototype customers and partners, and that's been very very interesting. But again, nothing moves as fast as you want it to.
Of course.
And then it's frankly just a question of time, right? It's time, money, and talent. You just want more of all three. One thing that actually, if you got a little more time, we could expound upon a bit, is this shift over to mobile AR, right? One thing we're seeing is all the projects that got spun up, the people who are interested in talking about 6 months ago, are now passé. The new shiny object is mobile AR, which is great. I mean, I think it's a big deal, and in the span of just a couple of months, we're looking at hundreds of millions of connected devices that need holographic imaging.
Yeah.
Right, with ARKit and AR Core.
Interesting.
Well, that represents a monstrous change in kind of priorities and milestones for us. The good news is we were still working on our core tech, so it actually hasn't changed anything. But we are still running around peddling our demo with the VR headset, which looks very 2016. I mean,
nice. Yeah, things are moving fast, and it's interesting too. It's kind of a domino effect of the fact that AR Core and AR Kit, in taking a software-based approach as opposed to hardware, have equipped hundreds of millions of existing smartphones out there, which then becomes attractive to developers to develop content for that larger installed base, just from kind of business principles. And then that enables all kinds of kind of supporting technologies like what you guys are doing. So it's this kind of like ecosystem domino effect that really, it makes a lot of sense that you guys are looking at that now.
It's convenient for short attention spans, right? I mean, I think that we're seeing a VR uptake curve that pretty much mirrors the iPhone uptake, to be honest, which everyone should be excited about. It should be amazing. Yeah. But people are already getting antsy. And so the fact that we can lean back and continue to build on the mobile ecosystem without having to wait for an entire, product turnover cycle, so some new hardware tech gets out there, is it's a blessing. It's amazing.
Well, that's exactly what it is. It's a stepping stone, and it's a stepping stone for the people that started this, like Apple with ARKit, Facebook's actually a better example, because with camera effects, which is their kind of developer platform for AR graphical assets, they're waiting for the day when the Oculus Rift and other kind of, headset-based VR is going to be more ubiquitous. They realize that's probably 5 years away. So in the meantime, the stepping stone is mobile AR. And I think Apple has, for the same reasons or for similar reasons, kind of blitzed ARKit before they get to a more glasses-based AR experience. You could say the same for Google and kind of everyone going after this. So, everyone involved, this is, I think, a good stepping stone, and it sounds like that's the same for you as well. So we're going to have to wrap there. I want to thank you, Ryan, for joining us. It's been fun.
Cheers. Thank you, Mike. Really appreciate it.
Yep. And thanks all of you for watching. And stay tuned for more episodes and more published material, market coverage, insights, and lots of other formats we're developing at Artillery, which you can find at artillery.co. Especially check out our new research subscription service, which you can find at artillery.co/subscribe. So this has been Artillery Innovators. I'm Mike Boland. Thanks for watching.